Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at integration using the reverse chain rule. So before I begin the video, please, I would advise you to have a look at two of my previous videos, that is the basics of integration and also differentiation using the chain rule, as those two videos would be extremely crucial for you to lay your ground foundations of integration using the reverse chain rule. So without further ado, let us begin. So from our knowledge of the chain rule, we know that a chain rule is a method of differentiation that is used to differentiate certain expressions. For example, if we have something like x minus 4 all squared, okay, don't need this now. One way you can differentiate this is by expansion. So you would have x squared minus 8x and then plus 16, and then differentiate them individually. But as I've said before in my video under the chain rule, what if you had something like x minus 9 all to the power 7? You wouldn't want to expand this, because that's just a waste of time. So you would use the chain rule. So all you would do is just simply times this by the coefficient in front, which in this case is 1 since there's nothing there, subtract 1 from the power, and then multiply all of that by the derivative of what's inside the bracket, and the derivative of x minus 9 is simply 1, because if you differentiate minus 9 you get 0, and if you differentiate x you get 1. So you would now have 7 into x minus 9 all to the power 6 times 1, which is the same as 7 into x minus 9 all to the power 6. Now that's for differentiation. Now how does it work when you have to integrate using the reverse chain rule? Now let's take this example again. Let's say our expression is still x minus 9 to the power of 7. So when it comes to integration, we know from our basics of integration, if you recall, our basics of integration says that if we have x to the power of n, then our integral, if we want to integrate this, would be x to the power of n plus 1 all over n plus 1. That's all over the new power. And then depending on whether it's a definite integral or an indefinite integral, you add the plus c. If it's an indefinite integral, meaning if you just have the sign, then you add plus c. If you have your limits on your integral, that is, maybe the upper limit is, or the upper bound, same thing, if it's 5 and the lower one is 0, then you would not add your plus c. But in this video we'll just be looking at indefinite integrals, that's without the bounds, so we would do plus c. Now this is the basic integration, but now again in this case we have to use the reverse chain rule, and to an extent it's basically the same sort of fundamental. It's just that there are a few modifications. Now all you have to do is simply again add 1 to the power and divide it by the new power. So you now have x minus 9 all over 7 plus 1, which will be 8. So we can just write 8 here. Let's just get rid of 7 plus 1. 8 all over the new power, which is 8. Now it's not done over here. The additional step you have to take is that you have to multiply this by the reciprocal of the derivative of inside and flip the sign. Now this is how it works. So now all you would do is you would times this by the derivative of what's inside. Now coming to the flipping the sign part, sometimes, well actually most of the cases that does not apply. You don't flip the signs. You flip it in higher levels of integration, but not in this level. We're still at the basics, so I think you don't need to worry about flipping the sign here. So just times it by the reciprocal of the derivative inside. That's the numerator becomes the denominator, and the denominator becomes the numerator. Now in this case, if we times by derivative of what's inside, that's 1, and the reciprocal of 1 is still 1, so you just times it by 1. So essentially you simply have the same thing, x minus 9 all to the power 8 over 8, or you can write this as 1 over 8 into x minus 9 to the power 8, and then don't forget to add your plus c. Now, one good thing about integration is that you can always confirm if it's correct. So if you differentiate this now, you should get your question back. You should get back the original expression they asked you to integrate. Now, using the chain rule, as we know, if we differentiate this, we have our dy dx to be 8 times 1 over 8, that's 1, so we can just write 1 for now, into x minus 9 to the power of 7. And when we have 1, we can just not write anything, just leave it. And this is what we had, this is what we were integrating in the first place, x minus 9 to the power of 7. So that's one advantage, and it works both ways as well. If you're asked to differentiate something, and when you get your final derivative, you can integrate that and see if you actually get the asked expression they asked you to differentiate. So that's how it works. Let's go and dive right into our first example. Our first example is to find the integral, or to integrate x minus 2 to the power 4. So very simple to the example we just did earlier. Of course, make sure that when you are solving, you make sure you have your sign. We are integrating x minus 2 to the power of 4. So simply do x minus 2 into the power of 4 plus 1. You add 1 to the power of 5, all over the new power, which is also 5, and times by the reciprocal of the derivative of inside. The derivative is 1, and the reciprocal of 1 is still 1. So this will eventually give you the same thing, x minus 2 to the power of 5 over 5 times 1. Or that is basically the same thing, so yeah, you can just leave it here. Of course, this can also be written the same way as 1 over 5 into x minus 2 to the power of 5. Same thing anyhow. If you want to leave it like this, it's correct. If you want to leave it like this, it's correct, of course, unless the question specifies otherwise. And then of course don't forget to add your plus c, because this is an indefinite integral, so you have to add your plus c. Right, on to the next example. We have, it says to integrate 28 bracket 2x plus 5 to the power of 6. Now this one is slightly different since we have a coefficient in front, but let's see how it goes. We are to find the integral of 28 into 2x plus 5 to the power of 6. Now, same thing, we don't bother ourselves with the coefficient yet. We do the basics first. We add 1 to the power and then divide it by the new power. So we have 28 into 2x plus 5 all to the power 7, because 6 plus 1 is 7, divided by the new power, which is 7, and we times this by the reciprocal of derivative inside. If you differentiate what's inside, if you differentiate 5, you get 0. If you differentiate 2x, you get 2. And the reciprocal of 2, because you know 2 is same as 2 over 1, is 1 over 2. Reciprocal is 1 over 2. You just switch the denominators and the numerators up. So you times this by 1 over 2. Now when you get to this stage, you can use your calculator, of course. There are two ways of doing this. Either you do 28 divided by 7, so that should be 4, and then times it by 1 over 2, that's 2. So you can do it like this, or you could do 28 times 1 over 2, and then divide that by 7, you get 2. But I would say just do 28 divided by 7 and then times that by 1 over 2. I think that's the quicker method and the easier method and the safer method. Less chances of you getting confused. So 28 divided by 7, that's 4. So we essentially have 4 into 2x plus 5 to the power of 7 times 1 over 2. And this is the same as 2, because 4 times 1 over 2 is 2. So it's 2 into 2x plus 5 to the power of 7 plus c. Again, I'm just going to do this for this example, but you can do it for the other examples as well. You can integrate, differentiate and find the original integral that they asked us. So the original integral they asked us to integrate was this, 28 into 2x plus 5 to the power of 6. That means if we differentiate this, we should get the same thing. Now if we go on with our differentiation, we know we do 7 times 2 first, so that's 14, into 2x plus 5, all to the power of 7 minus 1, that's 6, times the derivative of inside, that's 2, and this is 28 into 2x plus 5 to the power of 6. And that is the very same thing we were asked to integrate. Yep, here it is. Yeah, right, let's move on to the next example. Next example I have says, or rather instructs me to integrate 1 over 2x minus 1 to the power of 4. Now this requires a bit of manipulation. We know if we were to rewrite this, this is the same as 2x minus 1 all to the power of minus 4. So from here we can continue and integrate 2x minus 1 to power minus 4. Again, same procedure, we add 1 to the power and divide everything by the new power. So 2x minus 1 to the power of minus 3 all over minus 3 times the reciprocal of the derivative inside. Derivative of 2x is 2 and reciprocal of 2 is 1 over 2, so times 1 over 2. And you can simply do 1, because you know there's a 1 over here, so 1 divided by minus 3, that's minus 1 over 3. And then times that by 1 over 2, which should be minus 1 over 6. So minus 1 over 6 into 2x minus 1 to the power of minus 3 plus c is the answer. You can of course differentiate this and then see if you derive this again, and if you do, then that means your integration is correct. On to the next example, I have to integrate 3 over the square root of 5 minus 2x. Again, this requires a bit of manipulation. We know this is the same as 3 over 5 minus 2x to the power of 1 over 2. Remember, anything that's square rooted is to the power of 1 over 2. And this is the same as 3 into 5 minus 2x to the power of minus 1 over 2. When you take anything to the power to the numerator, the power becomes a negative. So this is what we're essentially integrating now. So we're integrating 3 into 5 minus 2x to the power minus 1 over 2. If you integrate this again, basic structure, 3 into 5 minus 2x to the power minus 1 over 2 plus 1 is positive 1 over 2. Divide that by 1 over 2, times it by minus 1 over 2. Now why minus? Because if you differentiate minus 2x, you get minus 2. And the reciprocal of minus 2 is minus 1 over 2. Minus sign stays. Whatever the sign stays. And just the numerator is only to flip. So again, 3 divided by 1 over 2 is 6, and then times it by minus 1 over 2 is minus 3, so we now have minus 3 into 5 minus 2x all to the power 1 over 2 plus c. And you can rewrite this, because if the question does state to give your answer in terms of a square root, then you know that this part is the same as 5 minus 2x, the square root of 5 minus 2x, so minus 3 square root 5 minus 2x plus c. So that is how you do that question. Now again, to emphasize, no matter what is in your brackets from the start till the end, whatever is inside the brackets, whatever variable, whatever number, they always stay the same. They don't change. It's the variables and the constants and the numbers and the powers and the fractions around them that change, but whatever's inside the bracket is meant to stay the same. Do not change it in any way. Do not try to manipulate it, because that would result in a wrong answer. Next example asks me to integrate 1 over root of x. Okay, interesting. So again, a bit of manipulation required here. We know this is the same as 1 over x to the power 1 over 2, because anything with the square root is simply what's inside to the power 1 over 2, and it's the same as x to the power minus 1 over 2. So this is what we're integrating. Integrating x to the power minus 1 over 2. And if you integrate this, again, same process, x to the power minus 1 over 2 plus 1, that's 1 over 2 all over the new power, which is 1 over 2 as well. And then you times it by the reciprocal of x, which in this case is still 1, so still 1. And we know that there's a 1 over here in front as well, although we haven't written it, because we know that whenever there's no coefficient it means 1. And if you divide 1 by 1 over 2 you get 2. So the final answer is 2x to power 1 over 2 plus c. Again, if you differentiate this, you should get the original integral back. Let's just quickly do that for this question. Our dy dx would be 1 over 2 times 2, which is 1, so leave x over here, and then 1 over 2 minus 1 is minus 1 over 2, and this is what we were integrating after we manipulated the original question. Obviously, this is what we had originally, and this is how we manipulated it to be, and that is essentially what we ended up in the end after differentiating our integrated answer. And on to the final example of this video. It asked me to integrate 2x minus 1 to the power of 4 minus 3x minus 1. So we've got more than just one thing to consider here, we've got two others. So let's take it step by step. Let's start with this one. Again, integrating all of 2x minus 1 to the power of 4 minus 3x minus 1. Integrating this part here, we would get 2x minus 1 to the power of 4 plus 1, that's 5, divided by the new power, that's 5, times about 1 over 2, because that's the reciprocal of derivative here. So let's keep this in brackets. Derivative of minus 3x, so we have minus 3 x to the power 2, because we know this is to the power of 1 here, because there's nothing, so we assume it's to the power of 1. And then we add 1 to the power, which in this case would be 1 plus 1, that's 2, and divided by the new power, so over 2. And from my previous video in basics of integration, we know that whenever you integrate a constant, that's 1 or 2 or 3 or 999, it's always going to give you x. So this is going to be minus x. Or basically, if it's 999, then we give you 999x. That's what I meant to say. So simplifying all this, over here we would do 1 over 5, and then times it by 1 over 2. That's 1 over 10 if I'm not wrong. I'll just calculate that real quick. Okay, yeah, it's 1 over 10, so 1 over 10 into 2x minus 1 to the power of 5. Then this is minus 3 over 2 x squared. You can simply write it in the fraction form, or if you want, you can also write it as minus 1.5 x squared, although I would highly recommend you write it as a fraction. And then minus x, and obviously the plus c, because all of this is an indefinite integral. If it was a definite integral, we would have our bounds over here, x and y, and we would input them into the x place over here. So that was how to integrate that final example, and that indeed brings us to the end of this video. Thank you for watching. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe. Thank you for watching. Have a nice one, guys.